Welcome again all to our second session of drone series. Now let's welcome for of our moderator, Nisreen, my colleague Nisreen. She is the East African Zonal Coordinator of African Women GIS. She will moderate this session. Hi Nisreen, can you hear me?
Yes, I hear you.
Okay. The floor is yours. You can start this session.
Okay, good evening, everyone. Thank you all for joining us today. I'm Nisreen Mahmoud, East Africa Zone Coordinator, and will be one of the moderator of these sessions with my colleagues. So welcome again, and thank you for joining us in the second session in the drone series, From the Skies to the Future, exploring drone application in the various industries. Second session, drones solution integration with GIS technology. Welcome also for our colleagues, Safinaz Mubarak, African Women in GIS Northern Africa Zonal Coordinator. I'm Nisreen, as I mentioned before. Damilola Olufemi, Administrative Manager, Sheflies. Dr. Noha Abdelwatth, African Women in GIS Events and Training Coordinator. Carol Nigerie Kiarie in the events and training team of African Women GIS. Today we will discussing about the topic of drones, and we will give some time for questions and answers at the end of the session. We will present a brief overview about our two communities. So we are a community made up of African women around the world who work, study, or enthusiastic about the geospatial industry and its related field. The community aims to allow its members to be themselves, create networks, gain mentors, get careers advice, partake in geo projects to improve their portfolios, access job opportunities, as well as geo course information, and showcase their work to the world. This it's brief about African Women GIS community. The second community, Sheflies, warm greeting. Sheflies is a community aiming to strengthen and empower females in STEM, science, technology, engineering, mathematics, particularly in the unmanned aircraft systems, UAS industry. By driving early development of interest among young females in all relevant sectors while exposing them to required knowledge and skills through mentorships, networking, and engagements. This is about Sheflies community. So today and in this evening, we glad to have Mr. EPHRAIM DANFORD Jr. from Tanzania. He is a GIS data and environmental expert, Geospatial World 15 Rising Stars 2021 award winning, Master of Science in Geographical Information System from the University of Dar es Salaam, Baccalaureate degree in Geography and Environmental Studies, Advanced Certificate in GIS IT from ADHI University Center of Information Communication Technology, worked with the USAID, WHO, TNC, Doctors Without Border, MSFCH, Humanitarian Organization, certified drone pilot, part-time drone instructor to CATC, member of AFCOP, Africa Community of Practice and East Africa Geospatial Forum. Welcome, Mr. EPHRAIM DANFORD Jr.
Thank you very much, Nisreen. Thank you very much for the introduction. Good morning, good afternoon, and good evening from wherever you are listening or you have joined this session. As Nisreen mentioned, my name is EPHRAIM DANFORD. I'm from Tanzania. I'm a GIS environmental and drone expert with a long industry of decades now in utilizing GIS as a solution in different sectors. So I'm very happy to have you here, but also I'm very happy that African women in GIS, as well as Sheflies, they have managed to organize this kind of initiative in order to increase their awareness and to train other people to understand the potential that lies within the GIS and drone technology. So today, I'll be sharing some few things from my end, sharing some experience that I have, but knowing that this is a learning platform, this is participatory, so we are also open and eager to learn from you guys. So be free to put your questions on the chat, as Nisreen said, and at the end we'll open the platform to discuss together. Do you see my screen, everyone? Thank you. So to start with, from drone solution integration with the GIS technology, I would like to have a brief discussion on the GIS concept, but also we will look on the drone concept. After that, we'll look on how drone is perceived in geospatial industry. We as people from GIS and remote sensing, how do we perceive the drone technology? Because the drone as a technology have been utilized by different sectors, by different people, but we as a geospatial people or geospatial industry, how do we perceive the drone technology? But also, we'll look just in a very snapshot, how drone transform the way we capture data across different sectors. Because at the end, you might agree with me that drone has emerged technology that many sectors have been utilizing it in data acquisition, starting from mining, industry or mining sector, agriculture, engineering, environmental, forest, wildlife, and so forth and so forth. So we have been adapting this technology. So we'll see in just a quick how the drone transformed the way we capture data across different vectors. But also we will have a discussion on drone solution, integration of GIS technology, considering that GIS and the remote sensing is the independent technology that have been there for quite some time. And the drone as a new technology to civilian, to domestic users came in. So how this integration has much potential and benefit to us as a user. And lastly, we will pause on the lesson learned from different industry. And from there, I would wish to hear also from other people with experience, the lesson learned from this integration or adapting a drone on the GIS work and the way forward, moving forward. What do we need to do as the people who are in a GIS technology industry or GIS sector to continue utilizing the potential of drone technology as a part of solution. So this will be our main focus of discussion, and I hope moderator will be guiding us through until the end of this session. I'm glad I saw different people from GIS industry, but also I know that some people from drone industry, but there's some people who are doing both. So I think it's also a good platform to share this experience. So to start with, when talking of GIS concept, GIS can be termed as a technology, or GIS can be termed as a software. But generally, you will agree with me, when we are talking of GIS, the concept behind is the system that designed to capture, to store, to manipulate, to analyze, to manage, and to present or visualize all type of geographical data. And this geographical data, it links the location. It links the location data, which include latitude, longitudes, codes, location codes, and the database, the attribute. So GIS links these two things, location information and the database, where these informations, they enable person to visualize or to understand the pattern, trend, and relationship of different phenomena. So this is the general term, how we can say that the GIS concept. It's not really definition of it, but the concept of it is more of how it links location data and attribute data or non-location data, and to get the picture, to get the pattern, the trend or relationship of a particular phenomenon. So here I have 4 things. For some colleague of mine, they may tell me that there is 5 things, but some other things are coming together. And this sometimes we call them as a components. So when we are talking of GIS, the GIS has the component. And these 4 things here are the main fundamental or the base of the GIS. We start with data. Talking of geographical information system. Geographical information system. So before even we go to the system or what the system is, we have the information. And we call it information because it's the processed data. So you get the raw data, you process it, then you get information. So that's why we have the data. And then we have the hardware. After hardware, we have the software. But by having hardware, and software and data, things cannot work itself. You cannot get the visual, you want to look at it. You cannot get the pattern, you want to check on it. So you have another important element or components of GIS, which is people, technical people, the GIS specialists, GIS technicians, GIS analysts. These are the ones with the skills that they have. They are the ones who give us the results. They are the ones who manipulate. They're the ones who command the system or software to analyze. They are the ones who manage the whole system. So when we are talking of GIS, the major components that form GIS is data, we have hardware, we have software, and we have people or methods. And these methods are guidelines, standard operating procedures, how we do things, which also is part of, who does that? It's a part of the role that are played by these technical people, which I was mentioning. In very quick, for anyone who is not much familiar with GIS, maybe you are using more drones on analysis or you are capturing or flying, you're not much gone in the GIS side. These things might look like very minor, but with my next slide, it shows the detailed. I know for those people who are in GIS, this is not new, it's familiar. It shows you more details, information that are captured on every single component. And that is what makes these components very important on the GIS life cycle. As I mentioned before, when we are talking of hardware, these are computers, peripheral, on which this GIS operates. You might have server, cloud, whatever, but those are hardware where we need to operate. We have network where we use to share the data, which we use to share the data from one location to another, from one person to another. By doing analysis, by doing different multiplication of data, at the end, you need to get the output. Can be the digital form or printed maps. You need to have a plotter, you need to have a printer. Those are hardware. When you come on the software, and you say that the GIS software provided the functions and tools users need to store. So we say the GIS is the system that is store, analyze. But where do you store? Where do you analyze? Is within the software. And here you have the database software. You have operating system software. You have network software. You have GIS software. So you find out in software itself, there are some few things which is very important within it. And then we have the data. And then we have the data. I will pause here because we all understand how much data is important in the whole cycle. One of the most important components of GIS is data. It is absolutely essential that the data be accurate so that you get the accurate results. The data are good, then you get the good result. You might have a good software, you might have a good hardware, but if your data are not okay, you might ending up not getting what you expected. In the data here, in the GIS arena or geospatial context, we have vector data, we have raster data, that's where now the image captured by drone come in. We have the image data, that's another from our satellites. We have those Landsat imagery and those kind of information. And we have the attribute data. The attribute data are the information about locations. So this is location A, and then what it's about. This is health facility. So mention the name of that location. That is attribute. That's attribute data. This is a health facility. It has been constructed in this year. Is owned by this person or organizations. It has this status in terms of usability. So those are attribute data. We call them data. And then we have the methods. Methods are well-designed plans and application specifically for business rule describing how this technology is applied. As I mentioned, you might have all structure are good and in place, but if there is no good guidance on how to utilize, how to provide analysis up to the end, you might ending up getting things which does not suit or facilitate the needs at a time. So this is specification standards, standard operating procedures. If you need a map, who to request it to, what's the process, what are the form to fill so that you can get this type of map. Those are methods. Those are the methods. And then we have another component, which is people. Talking of people, here is talking of me and you. We are the technical personnel who can make the whole system now work. We are the expert, we are the analyst, we are the technicians who knows when I encode this data, what will be the output on the other end. So GIS technology is clearly of limited value without people to manage the system and to develop plans for applying it. So users of GIS range from highly qualified technical specialists to normal user, medium user. So you might see that some people who are specialized on utilizing GIS. So those we call, they use GIS as a solution, as myself have been doing that for quite some time, just supporting other sectors. You support health, but using GIS. You support forest management by using GIS. But there are other who are utilizing GIS, but as a secondary part. It's not their primary role. You someone as a forester, as a wildlife manager, but you do some few things, some few calls on GIS to, assist you track your data, plot your coordinate, and those kind of things. So that's why we say, in terms of technical, we have range. We have different levels of who is doing what in facilitating the whole thing to work out. And here, for example, we have administrators, we have managers, we have GIS technician, we have application expert, we have end user, and we have consumers. If you develop a very good web map application and it helps people to navigate, those people who are using that web map to navigate in different locations, those are the consumers. They consume the product that you develop. So this is just the detailed core components, of GIS. On the other hand, we are looking on the drone as a technology. I was so fascinated at time that I realized drone itself is an acronym. It's an acronym which stands for Dynamic Remotely Operated Navigation Equipment. Dynamic Remotely Operated Navigation Equipment, that is drone. And is taken into different meaning based on the context. But just to give you what I understand, or what I've been exploring for years, that talking of drone is talking of any equipment that can be first operated remotely, but the second, which can navigate just by push of few things away from it. And that take us to the conclusion. That take us to the conclusion that there is drone which are flying, there is drone which are moving on ground, and there is drone which are moving below the ground. Most of them are submarines. If you are doing some survey on the sea, you might need to use a drone which will scan below the sea. You will need some equipment that can flow the sea. So this is just the general concept when we are talking of drone. For someone who came across unmanned aircraft, UAV, and start to understand, you call this UAV or drone for the lifetime, for the lifetime, someone will understand that, oh, so drone is only something which is flying, because you say drone or UAV. But this is a foundation of understanding the drone originated from the acronyms, which means dynamically remotely operated navigation equipment. And then when it comes now to I will not talk about the ground drones and submarine drone. We'll go on the flying one, because the session is all about flying. So with the mapping context, or our context, as we are focusing on flying drone, sky drone, you'll find that also we have some more details, explanations about different type of drones, and that I think that's where I will little bit dive deeper on that. So drone sometimes called UAV, unmanned aircraft vehicle. So in our context, we talk about the drone as unmanned aircraft vehicle, or some of us, we termed as RPAS, remotely piloted aircraft. You might find another word, RPA without S, that means remotely piloted aircraft, or RPAS, remotely piloted aircraft system. So as a general concept, UAV are used for observation and planning, and this technology is now available for the use in the emergency response field to assist the different crew members to respond to different emergencies like flood, there is fire, those kind of things. But also we see how drone is being useful in logistics nowadays. Medical are using drone to dispatch different samples and medicine, but also drone are used in environmental mapping, etc. But unmanned aircraft are classified based on different criteria, starting on the altitude range, but also the endurance. How long can it stay on the air flying, and how many kgs can this drone carry? And it supports the wide range of applications, and this includes the research, inspection, and other commercial applications that I know a lot of colleagues here, you might have different angles. You might have different angles that you have utilized a drone technology on one way or another. So to take you quick, we have three categories. We have drones which are using routers or just motors, the routers, multi-routers. So we have multi-routers. We have the fixed wings. I've tried to put the picture there. The drone which more of controlled by wings. And we have the third type, which is VTOL or hybrid. And the word VTOL means vertical takeoff and landing. Vertical takeoff and landing. So that's VTOL. So the hybrid one is mixing the feature of multi-router and the fixed wing. So it take off vertically as multi-router, and it transforms the system to have more endurance on the sky using the fixed wing. Then when it goes back on landing, it uses the router system. So this is just few category. I would be happy if other will come with something to be new things to learn today. But these are the three that are common. And I'm sure up to this point, there is no other in flying with this the category. So just to explain a little bit on the multi-router. Just to explain a little bit on the multi-router. Multi-router, it's having a large family. Multi-routers, it's having a large family compared to VTOL and fixed wing. So multi-router, for example, talking of Phantom 4, DJI Phantom 4, I'm sorry, I'll be mentioning these drone names. I'm sure there is no issue with it. Phantom or DJI Mavic 2 Pro, those are quadcopters. Those are quadcopters. So yes, we have another type with the six motors or propellers. We have another with the 8 hexacopters. We have like I mentioned, quadcopter. We have a tricopter with only 3 motors, and even we have a single one, like helicopters. It has a single propeller, but it's also a type of an unmanned aircraft vehicle. So in multi-routers, we have a variety of other family. But this slide here is, I put it here to try to share why a fixed wing and not quadcopter, or why hybrid. So we say fixed wing drones are typically used when surveying large areas, as they are able to fly for longer distance in time. They are mainly used to capture wide area image and to produce high resolution of mosaic maps. These drones can be operated from a single control point, and they can cover vast area very, very quick. I know I have witnessed here already, those people who are in here and have already used those fixed wing. They know the performance of the fixed wing. But also we have the quadcopters. On the other hand, a type of drone that are able to hover and take off and land vertically. They are ideal for surveying and mapping a forest area where you don't have a big area to descend and ascend, because fixed wing, it needs space. And that's where the development of VTOL or hybrid came in, to mix the strength of these two. Fixed wing and multi-routers, we get the hybrid, because there's some strength and weakness between these two. We don't say that the hybrid that does not have a weakness, not at all, not at all. But there is more strength on the VTOL compared to these two. So as I mentioned, and also you cannot quick do maneuvers or kind of the closer inspection by using the fixed wing, because the fixed wing, it takes large area. The way it operates is not easy to maneuver compared to multi-routers. That's why there is these two types. But lastly is, as I mentioned, in addition to these two, we have the hybrid drones or VTOL. These VTOL are becoming increasingly popular for surveying and mapping forest, not only forest, but also surveying in geology or mining areas, covering large areas, And these drones are able to switch between fixed wing and multi-router modes, allowing them to cover both large area and small area. Hybrid drones are also able to fly for longer distance and time, and they are typically more agile than the other types of the drones. So this, you'll find out this how it's interesting. And up to this moment, you start to realize why there was a new development of VTOL. So there was some challenge on fixed wing. There is some challenge in multi-routers. So people came up with an additional advanced drone so that at least to fulfill the needs of all other users. This is on the part of the drone concept. So let's see how we as geospatial people, we as people in GIS technology, GIS industry, how do we perceive a drone? Everyone, you will agree with me. Everyone, you will agree. Everyone, you will agree with me that to us, GIS professional, we use a drone as a tool for data collection. We use a drone as a tool for data collection. But also, GIS professional, we use drone because they make the process of creating accurate three-dimensional topographical maps easier, safer, and more efficiently. For those people who are doing, GIS, you will agree with me how costful it is to access high-resolution Landsat imagery if you want to extract some information. If you go for free, you get up to 10 meter, the accuracy or resolution of 10 meter. But if you want the highly resolution and the accuracy, you need to pay more. And sometimes you don't need large area. You find out with the satellite, there is some issue of clouds, there's a lot. But with drone, it makes it easier to acquire the data we need, the information we need, and to provide the output. Then just a minute. Sorry guys, I was trying to send to text the moderator. Moderator, please, if people can mute, but also switch off the videos. If people can mute and switch off their videos, it will be very, very helpful. So continuing with the how drone is perceived in geospatial industry. So GIS professional, as I mentioned, we perceive drone as a tool for data collection, but also we use drone because it makes it easy in the process of acquiring those information, especially in 3 dimensions. But also, drone can fly over dangerous or difficult terrain and return easily. So if we want to visualize or to capture the topographical data for a particular area with volcano eruptions or there is whatever terrain which is difficult for surveyors to move around with RTK, total stations and all those equipment, drone can facilitate the processing very quick. But also, drone is linked directly with remote sensing. Drone, and that's where now the theme of our session today is how this drone solution is integrated with GIS. Drone is linked directly with remote sensing, and this is happening when it is equipped with high resolution camera and the different sensors. Drone can capture detailed image and data from the Earth's surface, even in remote or inaccessible area, and those data can facilitate us to do a critical analysis in our research and facilitate making decisions. So as we all know, remote sensing as a process of capturing or acquiring data without being in place by using different sensors, you might get very good RGB data, near infrared data from thermal, but also NDVI from multispectral sensor, just by using drone. So you might agree with me that drone is linked direct with remote sensing, and that's why to us, people who are doing GIS, drone is very essential. Drone as an equipment, drone as a technology is very essential. This capability has made drone an invariable tool for various applications, and this including agriculture, as I mentioned before, forestry, wildlife conservation, disaster management, flood management, risk assessment. So there's so many areas that we as a geographer, we as a people who are in geospatial, we see and utilize at different potential level this drone technology. So to some point, you cannot avoid 100% the drone. And if you're not yet there, please start digging around how you can start integrate yourself with a drone, because it really make our life easier to some point. On the next slide, I want to share how the drone transform the way we capture data across different sectors. How drone or unmanned aircraft transform the way we capture data across different sectors. In every single area where the drone is operated, there is data. There is data behind it, which on one way or another can be utilized, can be integrated with the GIS and produce a result or a particular output. Talking of localization and tracking in the main industry, talking of public emergency service. Talking of public emergency services, talking of safety and security, talking of agriculture, talking of educational and scientific and technical service, talking of healthcare and the disaster relief, you have data. So wherever who is using the drone in that part, you have data. And those data at the end, it's only the spatial software they will be able to analyze them. Apart from videos that you are taking, even unfortunately, even the videos are geotagged. So even the videos, by using machine learning or artificial intelligence, they can be commanded, or you can do some module to identify some features from those videos because they have geotag. So you see, there's data that yet can be used to integrate with GIS. We are talking of spraying and dispensing. In agriculture, we spray. We have vector control, we spray. In real estate, we do inspection. In these areas, in these areas where drone works, we do a baseline mapping before. And when we do this activity, we can capture those data and process it back to our GIS software. It can be Global Mapper, it can be ArcGIS, S3 GIS, it can be QGIS, it can be ERDAS, it can, whatever software that having capability to process geospatial data. The data that are captured from all these activities can be utilized. The data that are captured from this activity can be utilized. You see different area. You see different industry. If not area, different industry, different sectors. How this drone are used. So keep in mind that there is data. If you go in inspection, they're using drone. There is data. Energy, transport infrastructure, mining and quarrying, real estate and industrial plants, public administrations, telecommunication. There is data that at the end, on one way or another, you will need this data. You will need a GIS or remote sensing software to process it, to get the meaning out of it, to inform other people. In delivery, you do cargo courier service. Spatial data might not be much relevant, but also you can integrate those data and track through mapping based map. So I keep understand that different sector that where the drone works, the GIS or the part of data processing is still there. Looking into the integration. Looking into the integration now of drone solution with GIS technology. After knowing what is GIS as a concept, I just give you as a concept, what is GIS? But also as knowing as a concept, what is a drone technology itself. And that's where now this integration it's happening. So we say drone and GIS remote sensing, GIS or remote sensing technologies have revolutionized the way we observe and understand our planet. These advanced tools have opened up a new possibility for scientists, researchers, and environmentalists to monitor and analyze Earth's natural resources, ecosystem, the climate change, and so forth in very easy and accurate way. The integration of drone and remote sensing or GIS technology has the potential to significantly enhance the Earth observation science, which where if you're coming from wildlife, that's Earth observation science. If you're coming from water sector management, forest management, all things related are happening on the Earth observation science. It will provide more accurately, timely, and comprehensive data than ever before. The integration of drone and GIS or remote sensing technology offer numerous benefits for Earth observation science. For instance, drone can provide a high resolution image and data at a much lower cost. At much lower cost than traditional satellite or aircraft-based remote sensing method. Guys, you might agree with me how tedious it is when you want to access some, and sometimes it depends, you know, it's not all the time there is a big budget for project. No, but sometimes you need the best output, the best result, but the budget is not there. But accessing the high resolution image with 4 bands or 3 bands sometime, or 7 bands from satellite suppliers and all that is very costful compare to use of the drone. But on the other hand, it also are tedious work sometimes, because you may need the data, but the data will take time to be available. I agree with the technology of the satellite, because with the satellite, it only gives us the previous information. It's the best archive. We can get data from, depending on when the satellite have been deployed or when the satellite have been manufactured, we get the data of over 10 years or 15 years or 20 years back. So that's the only advantage of satellite that I'm getting. But for the current information, for planning, we need to plan a new city. We need to plan electricity. It's easier to use a drone, and at lower cost we get high good data. So we say this makes it possible for researchers to collect more frequent data, for engineers to get more detailed information, for different wildlife experts to easily facilitate their activity about where they're monitoring, where they're assessing, whatever part of the Earth's surface, which can be crucial for monitoring changes in ecosystem, land use, climate, and so forth, as I mentioned, development, urbanizations, and all that. Moreover, drone can be deployed quick and easily. Drone can be deployed quickly and easily, allowing the scientists to respond to emerging issues or events in real time. We have a flood. We need an immediate response to see how much the flood have destroyed the village or farms or whatever. We deploy drones. Once it captures the data, we process the data quick. We can calculate the area. We can calculate the volume of water based on the 3D. So you may find how this integration is useful. This is particularly important in the context of natural disaster, such as wildfires, flood, or landslides, where timely data collection can be critical for informing emergency response efforts and assessing the extent and the damage. How do we calculate quick the kilometer squares, the square kilometers of the area that have been burned or destroyed? In real time, we deploy the drones, we process the image, we digitize the area where it's been destroyed, we calculate quick. So you can see the integrations of drones as a tool for data collection in our context as a geospatial, and how it facilitates the quick process on utilizing or responding to some issues. So specifically, when we are looking on the GIS now, I think my drawings is clear, visible, that you may have a drone as a tool for data collection, but on top of that, in that drone, you may have different sensors. Maybe you have mounted RGB camera, high resolution RGB camera, or in that drone, you have mounted a multispectral, which will give you some NDVI and some other bands for forestry monitoring or agriculture. But also on the same drone, as a vehicle, you can mount LiDAR. You can mount LiDAR. So an unmanned aircraft can give you a room to change different sensor based on the use or based on the requirement for you to acquire the data that you want. Once that data is acquired, is directly compatible with multiple or different GIS platform. I've used the reference here of ArcGIS, but the same, it can be done by using QGIS, Quantum GIS. It can be integrated into Global Mapper software for mapping, and so many other software to mention a few. In ArcGIS, if you allow me, in the ArcGIS, why I shared this reference as ArcGIS, because it has multiple extensions where you can extend with the data from drone, you can utilize in different parts. For example, in that dashboard, operational dashboard, you are monitoring the forest and you have the dashboard, whether it's linked to Power BI, a dashboard, or ArcGIS dashboard. You can be able to publish an image direct from, you can be able to publish image direct from the drone. You process them and to your dashboard. So if you are monitoring forest and you are taking the picture quarterly, after every quarter, you can be able to overlay these different automosaic in a particular operational dashboard, and you can see the changes in different indicators, so it can inform you. But you can also integrate with Application Studio, App Studio, where you do some development. For those who are developers, you can develop an application based on a particular needs, but you need some input from drone imagery, and that can be linked directly. For those who are doing open source development with the web map service, you can upload your image from drone in any platform. So this is a true meaning of the drone solution integration with GIS, that you can get a best output or result from drone, but by using geospatial software. I know someone must have the question, or might have the question somewhere now, how this drone data is generated, or what the whole process. First of all, we have multiple software out there for planning, using how you can map by using drone. But again, there is a specific workflow. There is a specific workflow that you need to follow so that drone can give you a specific data that you need. We have additional technology in the drones that can facilitate you to get the accurate data. Here I'm talking of RTK, the drone which has RTK modules, real-time kinematics. But there is more advanced, the PPK, there is drones which have built-in pre-processing or post-processing. The pre-processing capabilities. All this is to ensure the accuracy of the data. So how drone data generated? First of all, we plan the mission. We need to understand where are we going, or are we supposed to capture the data? That's our field, that's our area of interest. We need to understand the location. We need to understand the location where we need to capture the data. If necessary, we do a ground truthing. if the area is accessible. If the area is not accessible at the time, yet we can still use a different platform to do mission plan. So mission plan, it gives you a clear picture of the usability of the drone. The drone will use how many hours to fly, will use how many power in terms of battery, what do you need to have? But in the drone industry in general, there is a lot you need to plan during the mission plan. Not only how you will capture data, but there are some other logistics, which I'm sure African women in GIS, they will give me a chance another day to talk more on drone logistics and all that. Because at some point you cannot fly drones if you don't have permit, you know, there's those things. But at least the first level you need to understand is the mission plan. Then we have data capture process. Once you have identified and create your mission plan, then you deploy drone and it capture data. I don't know how much clearly my slide is visible, but in my slide, I have 3 segments of picture. The first picture on the top is RGB. The true image with true color, that is normal camera. That is normal sensor. It gives you a RGB. RGB stands for red, green, and blue. The combination of these 3 bands, it gives you the true color. The middle one, it's an infrared. So RGB plus near infrared. RGB plus near infrared. The third one is the image with NDVI. The image with NDVI. And that is dependent on how you use the color lamp to analyze if you're looking at the vegetation index and all those kind of things. So this is the process. It just, the picture shows the process data capture with different sensors and give you those kind. But once you have the data captured, you review the data that have been captured. You review the data that have been captured, and that is data review, where now the processing process starts. You review the data. If you see there is in my slide here, there is big picture, and there is small pictures. These small pictures are the original pictures that taken from the field. Then you review them before starting processing them by stitching, doing some image alignment. And once you did some image alignment, you process them to get the cloud, to get the point cloud. Once you get the point cloud, you create the digital surface model, then the digital elevation model, then lastly, you get the orthomosaic. And that's where the last process of mapping, because mapping is not only ending by getting this orthomosaic. This orthomosaic is just the data. So you might add some other, or combining contours, or combining the contours and digital elevation model. That's what mapping come in. That's what or where mapping came in. As we know that, or you may agree with me that mapping in cartography is a process of making map. So once you process the data, that is not a map. Now you need to identify, if we're identifying or extracting some information, giving it a title, putting some legends and north arrow, and all those components of map. That's where the mapping process come in hand. Now, my last part, I would like to share the lesson learned from adapting drone technology or drone solution with GIS or remote sensing technology. How the integration, the lesson learned from this integration of these 2 technologies. First, update skills time to time. That technology keep changing. And to advance, to progress, to grow, we must be updating our skills to be compatible with the emerging technology. You might be very good GIS personnel, but if you are stagnant, that different tools are coming to facilitate the acquisition of the data. If you don't adapt them, if you don't update yourself, then you'll be left out of the bus. So one of the lessons learned is to update skills time to time, skill that is relevant to what we are doing. But also learning extra. Updating skills with learning extra is different. Learning extra is sometimes to understand the big picture outside technical know-how, to understand the big picture outside what we are doing every day as a technical people. So that comes through connecting to different sectors, connecting with people from different sectors. I've been using GIS in the health sector, doing in malaria as a disease, doing in epidemiology. I've been doing GIS in vector control. I've been doing GIS in the issue of wildlife management, water sector, economic growth. So that is where the learning extra comes from, understanding the other sector needs because they have the data. So as a GIS personnel, you know where to chip in. But if you are just a software guy, not knowing whatever is happening outside, it might be difficult to capture everything which is changing. But also engage yourself. Engage yourself means I'm encouraging, you might be in the position where you don't have even a drone, but find people who are utilizing drone and see how you can connect yourself, understanding the drone concept, the drone technology, and understanding the data that those people are collecting. What are they using? What software are they using it? I'm sure out of 5 software that they're using, 2 or 1 might be one of the software that you know, which is geospatial. But also, lesson learned from all these changes is resilience. We need to survive. As long as we are in the technologies keep changing. We are people, unless we die, but we are not. We are not changing day to day. Rather than we need to adapt. So if you are not adapt, you will perish. And that is the lesson that we need to stay in the game. And that is what resilience is all about. So with the expansion of this ecosystem, it's what makes us exist and continue to strive in the industry, because we will be connected, we will understand what the industry needs, and we will be able to support and to provide the solution through this new technology integration. After saying this, taking this mic back to moderator for the question and answers, but as of now, Asanteni, thank you and merci beaucoup. Over to you, Nisreen.
Thank you very much for your valuable information. And we can have now to your questions, and we will answer it. Participants.
Yes, I see there are some few, Nisreen, there are some few questions in the chat box here. Like this, there is one, my friend here, Twagiru Mukiza. He asked the difference between geospatial and non-geospatial data. So just in quick, the geospatial data are those data which have the location component on it. So those data with X and Y or XYZ information, and the non-geospatial data are data which speaks more of a particular location, but they don't have location data like X, Y, Z. That's my quick understanding on this data that I've been playing with. There is other questions here. I got one guy I remember asked me, how do we interpret the data acquired by drones? So it depends. That is SOGI. This is from SOGI. This depends. This depends on what do you want to extract. What analysis do you do? So interpretation is what do you want to extract from the particular image? If you are using the a true image, RGB, where you see the true color, white is white, black is white, black is black, and you are taking, you took a particular in the forest maybe, it might be easier for you to see, okay, which area there is forest destruction directly, which area there is no destruction of the forest. So that's how we interpret it. But if you are using the multispectral, you need to have that understanding of how you analyze NDVI, those indices on the now that's a remote sensing techniques. How do you analyze those data? How do you interpret? If you see red, that it means the leaves or plants have more water, or they are dry, or they're in good health, or they're not in good health. So the interpretation depends on the level of the skills that you have. As people who are raising hands, please, please welcome.
There's someone raise her or his hand. I think someone have question.
Yeah, but also, Nisreen, someone asked if there is an organization certified drone in Africa. Yes, in Tanzania under Tanzania Civil Aviation Authority, we have CATC, Civil Aviation Training Center, is ICAO certified, so it's internationally certified with the drones. Yes, Caro, you asked how do you deal with the permits before a survey, but also this part, it depends on the country. It depends on the country where you want to operate. I know, like in Tanzania, the Tanzania Civil Aviations are the ones who custodian to give you, not to do survey, but permit to fly drone in the country or in whatever part. And once you get the permit as a drone operator, you need to have the license as a pilot, but also being certified with accredited organization. Oh, sorry. But on top of that, there is lower level, you need to notify the local leaders for your safety and all that. But in Tanzania, the procedures is very clear. But again, my colleagues who are in Zambia, drone is under Ministry of Defense. So you might need also to reach out to Military of Defense and get those A, B, C from there. No, there is to the permit as an operator, it is stands for 1 year. So annually, the permit is given annually, for example, in Tanzania. So you get this time until next year, then you renew it again. After that, you'll just be flying your drone because you have permit already, but just following the different standard, just few standard operating procedures when you are in the field.
Also, we have a question: how do interpret the data acquired by the drones? It's from Suji.
Yes, thank you, Nasra. I think I've answered that already.
Also, how can I use drone technology to map a study area for an article?
I'm looking for that question. How can you? Sorry, Nisreen, can you come again to that question? I didn't see it in chat. I'm trying to look it.
Okay, how can I use drone technology to map a study area for an article? It's from Mariam Hassan.
Ah, okay, thanks, Mariam Hassan. Yes, even a lot of people who are doing PhD, they're utilizing drone, and we have some reference. We have some reference of Tanzania where we supported some few PhD candidates, like the image that I was showing you here in my slide. This one, you see the part of the forest. You see this mapping the forest. This was the product that we used to capture during the training with the PhD candidate who were doing a forest and carbon PhD in one of the university in Tanzania. So we did that mapping for study. So it's possible. It depends on where you are and it depends on where you are and what do you want to map, but it's doable because you have the area of interest. You have the area of interest, and if you have access to drone, you can follow the procedures and deploy it. Please, can we have another session to show how drone data is used in ArcGIS? Yeah, once you have, just a quick, once you process the image by using different processing softwares, and you have orthomosaic, and you have orthomosaic. That orthomosaic as an output can be directly used in the ArcGIS software. I'm using ArcGIS software myself. I've been using for quite some time. I'm using ArcGIS Pro. So most of the time, I process the drone image from different software, then I digitize, I extract some information, I finalize my map in ArcGIS software, and it's doable as long as you have those mosaic. Yes, I got this. Sorry, this came as a direct message. Please, can you recommend a drone for me? Yes, but the drone recommendation comes with the use. It comes with the use.
Also,
what do you want to use for? If I can say you use T30 Agra for spraying, and unfortunately we're not spraying anything. But if you are doing a videograph, I might so the use of drone also determine the recommendation. I think you can, because of the time, I can recommend some of you guys to reach out and follow me on the LinkedIn, and you can ask me all questions, and we can extend this discussion as much as possible. In LinkedIn, I spend some time interacting with people. So over to you, moderator.
Okay, Mr. EPHRAIM, I think there are also remote sensing, Landsat data, and drone data, which is more accurate than other?
No, just first of all, as I mentioned, it depends on what the use you have. Because based on my use, a 10 meter might be the accuracy, because also the accuracy of the data it's a parameter. But in terms of resolution, if you ask me in terms of the resolution, the drone one is the best. There is no, you cannot beat drone. Yeah, it take image, you know, you get even, you can see even the flowers, the trees, that resolution satellite cannot give you.
Okay, it's clear.
Yeah, so after saying this, do we still have any additional question? If there is no question, please we'll leave to you, Nisreen. And I keep insist that you follow me. You follow me in LinkedIn, so that at least we can extend these technical discussions and give each other experience in answering all these type of technical questions. Thank you.
Well, thank you so much. I think Nisreen is out the session now. I think she has issue in the internet connection. There is some other questions in the chat box about how connecting GIS and geo-presence analysis. And another question about using drone technology and GIS to aid in firefighting in a country. Okay.
Sorry, Nisreen, was that the question?
Okay, the questions, the latest questions in the chat box from Suji about connect GIS and a media data. Okay, and measuring the locations for the geo-presence. Okay, geo-presence analysis.
Yes, as I can quick, I didn't get it well, but as I can quick say, you can do a lot of analysis, you can do a lot of measurement, you can do a lot of manipulation to data that you capture from drone. And the good thing that I like about the drone imagery, once you have the 3D data, you can even measure the volume. Volumetric analysis can be done easily by using the image captured by drone.
Okay, another question to use the drone technology and GIS to aid in firefighting. Okay.
The use of drone technology in firefighting. So that also is a part of the emergency response. When talking of emergency response, there is new drones. I wish I could be able to share, but there is new drone manufactured by Chinese that are capable of spraying, but also some capable of handling some equipment that can facilitate fire control. So there is. Okay.
Another question about the software. Which software is using better quality, ortho or DSM?
Which software is better for processing?
Yeah.
I'm trying to find that question that's here. Drone, which software is using better quality? in ortho and DSM. Yeah, this also is a matter of, you know, it's why do you have Toyota and I have Nissan? That's the thing, you get it. But truly, with my experience, drone to map is good, and especially when you are doing mapping, because you can be processing the image from drone for different purpose, for different use. But when it comes on the mapping, drone to map is the best software, but also Pix4D, Pix4D mapper is it's also a good and recommended software. Pix4D mapper. I wish I could be writing here. So we have drone to map, and then we have Pix4D mapper, but also ArcGIS Pro. ArcGIS Pro is good. ArcGIS Pro, it works. There is some features you can use it to process ArcGIS Pro. So these are the ones that I've been using. And again, the drone image, because are owned at individual level, it's not easy like you can get the open. People are getting for specific use, so they are not deploying openly. And it depends on the country. Some country like Tanzania, we had multiple projects from World Bank years back. So they were doing this Open Skies program, Ramani Huria program, Open Street Mapping. So they have some areas that they've been piloting doing drone capture image. You can find it in World Bank data portal. But I don't know about the other countries. If those projects with World Bank, they never happened, probably there is no such kind of data in open domains. So I will not assure you that where you can get the drone data on website, no. Most of them are captured specific, so it's hard to get them openly.
Thank you so much. Another question, still one question from okay, about which better, which best for sensor and okay, for sensor, drone and sensor. I think you mean the device.
So sorry, I'm trying to look also the question. I'm trying to find the question to get the.
Okay. Drone large data, which drone is best, and sensor which you use. I'm very sorry, my voice is not good. I can't.
It's okay. It's okay, Nisreen. Okay. So in terms of sensor, again, there is multiple sensor, but I use the Zenimus. I use the Zenimus X2S for RGB data. It really worked perfectly. But also, if you may use Phantom 4, it have a good camera, a good sensor for RGB. It have the good sensor for RGB. But also, if you are able to access LiDAR it give you more detailed data. LiDAR sensor, it give you more detailed data in terms of geographical data. So you capture a lot of information. So when it comes on analysis, you might find out yourself you have a lot of information by using LiDAR.
Still, we have two attendants who are raised their hands. So I will ask them to unmute. Okay. Actually, very interactive discussion. Thank you all. Thank you all, Mr. EPHRAIM. You are unmute now. You can ask your question.
Good evening, everyone. I believe I'm audible, right?
Yes, yes, loud and clear.
Okay, I was inquiring if it's possible, since the accessibility of these drones to us mappers is quite hard, and also the people who have the drones are very few since they're expensive. I was inquiring if it is possible that we can develop or a mobile game that can teach us how to use these drones, maybe in land mapping, engineering surveys, and all other mapping aspects. That's my question.
So you are asking about having kind of visual control that it can take you through how to fly, right?
Yes.
Yeah, there is. There is those. Although some of them they're licensed one, like DJI, they have one. And it depends on what training do you want. You can train it virtual. But also I think there's multiple source, like in YouTube, there's few accredited companies, organizations that they do that. And as I mentioned, the issue is these things is getting interested when you continue talking. So I know it will get more and more interesting. That's why I say let us catch up on connect on the LinkedIn, and I'm sure we'll be able to learn from each other a lot. Because I used to post those kind of things, but also it's easier, you know, to share some information directly when you have time to gather all those kind of information. Like now, I just remember one simulation is DJI, but there is multiple simulation for drone.
Okay.
Hello, please, can you hear me?
Yes, okay. Yeah, we can.
Okay, first of all, I want to say thank you for this wonderful program. Please, I want to plead with you if you can recommend a book for your slide on the components of GIS and GIS in general, because actually that's the course I'm offering now, and it's quite challenging for me, but with your explanation, I got deeper understanding. So I don't know if you can recommend a textbook or you have a handout that you can give me a link which I can have access to it. I'll be very grateful. Thank you.
Yeah, thank you very much. Nisreen, I think, if I may ask, I think we have contact of all people who attended this session, right?
Yes, we do.
Not really.
We
I don't really know if
we have the Nisreen. If we have the contact of all people who attended that, I think I will share some materials on GIS, specific on GIS, and I'll share some material from drones. Then we can create something like Google Drive. Then we pull all those information there related to GIS. Then we connect all members who attended this with that folder. So anyone can be chipping in, getting some materials, whatever they want. Because I have a lot of materials, so it's hard to it's hard to quick tell you which or whatever. I've been doing GIS for quite some time, so I have a lot material. I have it, but I think with that good modality, I can be able to share.
Okay, that's okay. Nisreen has left the chat, the session, but she'll be joining us later. So yeah, we can provide that contact for you, and then you can share all that with us. Thank you.
So please, again, I've shared my link. I've shared my link for the LinkedIn. If you saw it, you can follow, and then we will extend the discussion from there. Thank you very much, Nisreen, for having me.
Thank you.
Thank you, African Women in GIS and Sheflies, for this opportunity. I hope we'll keep in touch and continuing supporting each other on this kind of capacity building, learning, and reflecting on what we are doing in the industry. Thank you very much.
Thank you,
Thank
Mr.
you,
EPHRAIM.
Mr.
Yeah,
Ephraim.
actually, we learned today from you, and we are honored to have you today. Okay, Nisreen, the floor with you.
Okay, thank you for everyone, and thank you for you, Mr. Ephraim. We have two presentations about the two community. First of them is with Carol in the event of training team. It's about African women in GIS, and the second of them is for GIS community with Damilola Olufemi. Please stay with us, and thank you again for all participants to joining us today.
Thank you, Nisreen. Thank you so much, Ephraim, and I've learned so much today. I appreciate you creating the time to just share this information with us, and we don't take it for granted. Thank you so much. So I'm gonna get straight to the presentation. I'll be presenting on African women on GIS. We usually do this with our story maps that was created via ArcGIS story maps. Please stop sharing the screen.
Okay.
Yeah. Oh, sorry. Yes.
Okay. Sorry, Carol. Please, Mr. Ephraim, can you stop sharing? You can share now, Carol.
So can you all hear me? Am I audible?
Yes, we can hear you and see you.
Oh, okay. Thank you so much. So African Women in GIS is a community of African women that work together and study together on all things GIS. We are enthusiastic of GIS too. So you don't have to have studied GIS or be a specialist in GIS to join our community. So the community aims to allow all our members, not just all our members, to create network, gain mentors, get career advice, and do projects, portfolios through our guidance or the guidance of the community. So our members are African women, but we do sessions and trainings and inclusive sessions and trainings on every person who is interested in geospatial data and geospatial industry. Our mission and vision is to create a safe space for African women in the geospatial industry, irrespective of their career level. And our vision is to aim to bridge that gap in the African geospatial industry. Yes, what do we stand for? So we have 4 colors in our community that represent our African women in GIS. These colors include leafy green, pitch black, and our love for nature and geography and our environment. And pitch black entails the unity and support that we show all members in our community. Light gray is for gender equity, and pure white is for safety and safe space for everyone in our community and anyone who is interested in our community. So the community was started through two different groups. It started as women in GIS Nigeria and women GIS in Ghana. The Nigeria one was started by Chidima in 2017, and the women in GIS in Ghana was started in 2019. So Awigis was born as a result of these two women. Two great leaders came together and they thought it would be good to have an inclusive group and community for the whole of Africa. And this group was started in October 2019. We have very many members by now. This was written back in 2020. So right now we have members from all over Africa and also the world, as long as they have an African roots. So our growth is estimated approximately that much, and we keep on encouraging people to join the community. We are distributed all over the world, as I said, but mainly our members are from Africa. Actually, all the members are from Africa, but based in different parts of the world. So why did we create, why did this community come to be, and why does it exist? As you all know, our industry is male dominated, and we would like to encourage more women, especially African women, to get into this industry. So that was one of the reasons why it was started and why we keep on going and keep on encouraging and training and creating these events to encourage people to join the industry. So there's a lot of lack of female role models and career guidance, and we aim to bridge this gap by creating mentorship programs. We have a few mentorship programs that run throughout the year. We always advertise the cohorts that we are doing to be able to nurture and also create a mentorship for our young girls in the African community. So the community also aims to bridge the gap of inaccessible GIS jobs information. So we create information, we create availability of this information for everyone who is in the community. There's also an inaccessible and an unaffordable GIS events and courses in the African community, and that's why we have purpose to keep having events and training opportunities every month. Every month we always have a session for learning and to create awareness for everyone in our community and anyone who wants to learn. And then there's also a lack of GIS potential awareness. So we aim to create awareness on GIS, and also the lack of grassroots awareness. So we also aim to create awareness to our roots. So as I mentioned, the fundamental problems that we are trying to solve are African GIS industry and other STEM fields are dominated by men. There's lack of career guidance. There's inadequate school curriculum. There's lack of grassroots GIS benefits and application awareness to university students and also secondary school students. So we aim to create that, and most of our members, we always encourage them to go back to their schools, to their high schools, and create awareness of GIS and the benefits that it creates in this. So gender career tendency of some African parents. So career path programs that we're trying to solve are limited number of GIS related jobs in African country, inaccessibility to job informations, and lack of female GIS mentors, as I mentioned above. How are we contributing to this, to solving these challenges? By networking, by learning, through these training events that we always have, by mentoring the young generations to be excellent in GIS and to just understand everything that entails GIS, and also to create awareness to the African community on the benefits of GIS. Community activities that we've done so far. In 2020, we did a webinar on Women's Day with the team, IWT team. Yeah, so we have a few more events that we do. Like I said, we create these events every month. We have a session. We just completed a session, another session like in April. Then we started this now, and it's still continuing. It's going to run all the way up to hopefully by November, and then we will have that. For our mentorship programs, we've had a few cohorts. This year, we will announce the date for the cohorts, for the mentorship cohorts for this year. Okay, so that is just a summary of our GIS. Our community has created a platform which is a source of motivation for African women. We have some social platform where you can follow us and get to know about this. Get to know about all these events that we host. We host mapathons too. We host everything that entails GIS. So in case you need to know much more about our GIS, go to our website. Noha has shared the link to our website and also to our LinkedIn account and Twitter account. Then you can go and get more details there. Noha also shared a form for joining our community, and nothing would make us happy to have you guys joining. I know there are some, there are male and other genders here, but our community is women-based, but all our events are completely inclusive of everyone who is interested to learn and to grow in the geospatial world. Thank you so much, EPHRAIM. Thank you. We've learned so much from you, and we can't wait to receive the materials that you will share with us so that we can share with everyone who attended our session today. Thank you so much. Over to you, Nisreen.
Thanks, Carol. And we move to the last presentation with Damilola Olufemi from Sheflies. It's yours.
Hello, everyone, and well done, Carol, with a wonderful presentation. And I must commend EPHRAIM for the insightful teaching. Like, I'm sure we all learned a lot. It is worth the time. So my name is Damilola Olufemi, and I'm representing the Sheflies community. Dr. Noha,
Give me a
please,
second.
Okay.
Give me a second. I stop sharing this. Just a minute. Okay. All right.
Okay, sorry, I will share now.
All right, thank you. As you all know, this program is powered by the African Women in GIS in partnership with the Sheflies community. And Sheflies community is all about a community that is passionate about the UAV industry. Yeah, it is an exclusive community for ladies, but also our programs are inclusive. All genders are welcome. Next slide, please. Yeah, so Sheflies is a community that aims in strengthening and empowering female in STEM. That is science, technology, engineering, and mathematics. particularly in the unmanned aircraft system, that is the UAS industry, by driving early development of interested young females, in the relevant sector. And it's so interesting that today we learned the full meaning of drone. Because before now, I think I saw it on the group chats, on the chat page, that someone said he or she did think that drone is just any flying object. But we learned that drone is dynamic, remoted, that is operated navigation system, equipment, yeah. So that is what we're all about. That is what we champion. That is what we promote. And we provide mentorship, networking, and other engagements in the STEM industry. So to encourage more females to develop interest in drones industry, especially from early years, and to inspire young females into self-discovery. Yeah, so our vision is to empower females in the drone industry. And how do we go about this, which is our strategy, is to close the knowledge gap among females in the UAS industry by building an online ecosystem through collaboration and engagements, which is one of the reasons why we are here today. So next slide, please. And our objectives include expose members to technical knowledge of drone applications, expose members to knowledge of what industry to apply drone skills to, foster collaboration and partnership among members, mentor young females on career development within the drone industry, circulate available industry opportunities among members to leverage on, provide members with skills and necessary to engage in the industry, and also organize trainings and programs that would help improve the drone knowledge of our members. And over time, we've had physical programs and online programs. So our capacity building is creating a network of knowledgeable females in STEM through stimulating discussion within the industry, with the industry experts. We're lending a voice, bringing together females and creating a platform for them to connect, engage, and thrive in the drone industry. Then industry relevance, being relevant and up to date with the drone industry, locally and globally, keeping up to date with dynamic and compliance with regulations, then maximizing technology, learning
Hello, is there any problem? Damilola?
I'm sorry for the network glitch. Next slide, please. Thank you. So you must have seen in the chat session, if you want to join the Sheflies community, there is a form there to fill. Kindly fill the form. It is exclusive for females, though I said earlier that our programs are open to all gender, but to be a part of the community, it is all female community. So, and also please kindly follow us on our social media. We have the Sheflies.org on Twitter. We have Sheflies.org on Instagram, and our Gmail. If you want to make any inquiry or for support or anything, you can reach out to us at shefliesdrone@gmail.com. And also we are on LinkedIn. You can search Sheflies Community on LinkedIn. Thank you.
Thank you, Damilola, for your great presentation.
Nisreen, we can't hear you. We lost you. What did you say?
I said thank you, Damilola, for your presentation, and ask Dr. Noha if she want to say something before we end the session.
Yes, thank you all. Thank you, Damilola. Thank you, Carol. Thank you. Thanks to all attendees today. Sure, thanks to Mr. EPHRAIM. The session was very active and inspired, and I hope see you soon in the session in the next session. Thank you all.
Thank you all participants for their contributions and time. And for more information, please contact us on the social platforms. Thank you again.
We will end the session now.
Okay, everyone, have a good day, and thanks for being with us in this day. We will end this session, and we looking forward to hearing from you all in the